Our new entry is called factoring out the GCF, which is the greatest common factor. And you should have this sheet as part of the packet. So after you've done the activities, you'd move on to the notes here, and we're going to follow these steps, and we're going to factor out the greatest common factor of a polynomial. Now, let's kind of talk about why we're doing this. Before, when we were multiplying polynomials, and we had a monomial times a binomial or another polynomial, we would distribute in. We'd distribute in and we'd get this polynomial that was simplified and there wasn't any multiplication. Now, as far as math goes, like in math terms, these mean the same thing. This is the same as this. They're just represented two different ways. And both ways tell us a different story. And that's what's important when we move forward through the rest of this unit and then even into next unit, because we're going to be taking polynomials, specifically trinomials, okay, and we're going to represent them in different ways so we can get two different sets of information, okay, and that's what's important. So this factoring out the greatest common factor is the very first step in kind of working backwards and representing a polynomial in a different way. And so let's open up this foldable and get started. We're going to start with this problem on the upper left, 18y squared minus 15y cubed plus 3y minus 6. And so when we're taking out a greatest common factor, what we're going to do is something called upside down division. So we're going to make an upside down division sign, which is just kind of think of a division sign like your long division, and then you're kind of making it upside down. And we're going to pull out a common factor that each term has. Okay, so let's first look for a number. What is a number that could multiply into 18, 15, 3, and 6? Or what number do those all have in common? And so right away I see that these are all multiples of 3. So I can take a 3 out of all of them. And I'm going to do that, and I'm going to do that in a different color. Alright, so let's take out a 3. So I'm going to put 3 on the outside because that's what I'm trying to take out. And I'm going to write what I have left after I take out that 3. So what I'm doing is I'm basically dividing each of these terms by the factor I'm taking out. So I'm dividing everything by 3. 18 divided by 3 gives me 6. And then I have the y squared. Minus 15 divided by 3 is 5. And I've got the y cubed. Plus 3 divided by 3 is 1, so it's just y. And then minus 6 divided by 3 is 2. Okay, so I could take out a 3. And now I want to look for anything else that has that is a common factor between all 4 terms. Is there any number that can go into all of these other than the 3 we took out? In this case, there isn't. Right, 2, 5, 6, there's nothing in common between those. And then look for a variable. Do they all have a variable that's common? Well, I see that this has a y, this has a y. There's no y here. So I can't pull out a y. So this is all that I can do for this one. Okay. So 3 is my greatest common factor. Okay. And then to write my answer, to write my solution, I put the greatest common factor on the outside, which is 3. And on the inside, it's whatever is left over after I take out all my greatest common factors. So in this case, that's 6y squared minus 5y cubed plus y minus 2. And there's my solution. Okay, so in math terms, right, they are equal, they mean the same thing, okay, but they tell a different story. And you'll kind of get a better idea of what that means in the next unit. Right now we're kind of learning that skill of manipulating the polynomials so they look different. Alright, let's move down to the next one here. So I've got 45x cubed y squared z cubed minus x y squared z plus 15x squared y to the fourth minus 5xy z squared. So I want to first look for a common factor, just a number. Do they have a number that's in common? I'm seeing a lot of 5s, right? So multiple of 5, multiple of 5, multiple of 5. But this one is not a multiple of 5. Okay. 3s? Nope. Nope, right, there's no number here. So there's not a number that I can take out. So then we look for a variable. Is there a variable that I can take out? What do all of these have in common? So let's first look at x. Do they all have an x? This one does, that one does, that one does, and that one does. So let's take out an x. So I draw my upside down division sign, and my common factor that I'm taking out is an x. And what is the result when I do that? So if I take an x away from this term, I still have 45. I don't have x cubed anymore. Now I have x squared because I took an x away. And I still have y squared z cubed minus, I took an x away, so this is just y squared z plus 15. Take an x away, and this becomes this x to the first, y to the fourth. And then lastly, take an x away, we've got 5y z squared. And now I want to look and see if I can keep going. Is there another x that I can take out? Well, let's take a look. This has an x, this one does not. So I can't take out any more x's. What about y's? This has a y, 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 and a y. So I can take out a y. And what is the result after I do that? So again, I have 45 x squared. I take out a y from the y squared. I just have y left over. And then z cubed. Minus, I take a y away. This becomes yz plus 15 x y to the third now minus 5. Take a y away, and I just have z squared. Now, are there any more y's that we can take out? No, there's no more y's. What about z's? So that has a z, that has a z, this one does not. So I can't take out any x's anymore, any y's anymore, any z's, or any numbers, so I think I'm done. So my greatest common factor is right here. X and y. And so when I write my final solution, the x and the y go on the outside. Okay? And then on the inside, what I have left over is right here. 45 x squared y z cubed minus yz plus 15 x y cubed minus 5 z squared. Close parenthesis. Alright, I'm going to do this one And you might start doing it a different way, but I want you to see what happens when I do it this way, okay? I'm gonna, it's not necessarily make a mistake, but I'm gonna show you what could happen if you don't take out everything that you can your first go around. So I've got this polynomial here, 32x to the fourth minus 16x cubed plus 8x squared. And I'm thinking, well, what number do they have in common? Well, I know they're all even, so I could take out a 2. So let's do that. And I take out a 2, and this becomes 16x to the fourth minus 8x cubed plus 4x squared. Okay. And now, is there another number that I can take out? Well, let's try again. So I could take out, well, they're all divisible by 4. So let's do it again. And let's take out a 4. So I get 4x to the fourth minus 2x cubed plus x squared. Then I keep going. So do I have any more numbers that I can take out? No, I don't. Okay. So what's next? What do we look for? Well, we look for variables. So I've got, they all have an x in common, so let's take out an x. This becomes 4x to the third minus 2x squared plus x. And we look again, do they have anything else in common? And they do. They have another x that I can take out. So I take out another x. And this becomes 4x squared minus 2x plus 1. I have to put a 1 here, okay? Because I did take away an x. That means there's just 1 left over. I can't just get rid of it. So remember that, okay? You have to put a 1 here. And what that leaves me with is these as my greatest common factors. Which I would then write on the outside. 2 times 4 times x times x. And then on the inside, I've got 4x squared minus 2x plus 1. And I can keep going with this part. It's kind of like when we were simplifying radicals and we started pulling things out. I can do 2 times 4, which would give me 8, and x times x, which would give me x squared. Okay, so this is what happens when you don't take out everything you could in your first go around. So you see I took out a 2, and then I took out a 4. What I could have done, instead of doing that in 2 different steps, okay, is I could have taken away 8. Alright. And here I took away an x, and I took away another x. What I could have done is just taken out 2 x's, or x squared. So you can combine those in one step. Okay. It works both ways. You'll still get the same answer, but you can do it shorter. Okay. And I'll start the last one and then you'll finish it. And I've got example problems for you to do as well. So here's my next polynomial. And I want to start taking out greatest common factors. So I do my upside down division symbol. And I notice that I've got, as a number, I've got 82, 16, and 8. Those are all even, so I can take out a 2. And I'm left with 41 x to the fourth y squared z cubed minus 8 x cubed y to the 7th z to the 11th plus 4 x squared y to the 9th z squared. And that's all I can take out for a number. Okay. Now, similar to the last problem, let's look for a variable. So they all have an x in common, right? They all have x's. How many can I take out at once? So at x to the 4th, x cubed, and x squared. So they at least have an x squared. So I'm going to take out an x squared. So it's kind of like combining that step. And what I have left here is 41. Instead of x to the 4th, I took away 2 x's, and it's x squared, y squared, z cubed, minus 8. I took away 2 x's, so just x left, y to the 7th, z to the 11th, plus 4. I took away 2 x's, so I don't have any x's left here. It's just 4y to the 9th, z squared. And then you keep going. When you're finished with this problem, have your teacher check your answer, and then you're going to do the practice problems on the left side of your book. So when you're finished with this one, you'll have your foldable here. You fold it like a pamphlet, okay? And you can put a piece of tape right on this edge here, or you can glue the back down because we didn't do anything with the back. So it's like that, and it opens up just like a book. And on the left side, you're going to do these practice problems here. I'm going to zoom in so that you can see it. So I have 7ab minus 35a squared b, negative 32 n to the 9th plus 32n to the 6th plus 40n to the 5th. And the last one is 20x to the 8th y squared z squared plus 15x to the 5th y squared z plus 35x cubed y cubed z. When you're done with those three, have your teacher check your answer, and then you're ready to move on to the practice.